Good afternoon. Today we are going over Notes 4.1, Equivalent Rational Expressions. So a rational expression is an algebraic expression whose numerator and denominator are polynomial functions. So here's an example of a rational expression. It's a fraction that has polynomials in it. Just like a numerical fraction, a rational expression is undefined when the denominator is equal to 0. So we want to avoid that. So the value or values that make your rational expression undefined are what we call excluded values. So excluded values. So remember, to simplify fractions, you can divide out common factors that appear in both the numerator and denominator. You can do the same thing when you're simplifying rational expressions. So there's going to be a lot of factoring in this unit so that we can reduce common factors. So first thing is, what makes your denominator equal to 0? We want to worry about that. So our excluded values. So r minus 9, if you set that equal to 0, r cannot equal 9. So that's our excluded value. So now to simplify, right, we're seeing if we can find common factors. So the numerator doesn't look like there's common factors right now, but I do notice the numerator has a GCF. So I'm going to factor out an 8. That would give me an r minus 9 over r minus 9. Now I have to see the exact same factor in the numerator and denominator. So the r minus 9s are going to reduce. So you get a and r cannot equal 9. So this would be your simplified answer. So example 2, again looking at the denominator, I can't really tell if there's common factors in the fraction. So I'm going to factor it. So we have x times x. So factors of 6 that give you 5, that would be 3 and 2. And just like the last example, I want to figure out what makes my denominator equal to 0. Those are my excluded values. So x plus 3 equals 0. So x cannot equal negative 3. X plus 2 equals 0. So x cannot equal negative 2. And then I notice the x plus 2's will reduce. So you have a 1 now on top. So it's 1 over x plus 3. X cannot equal negative 3 or negative 2. So there's my simplified answer. So I factored it to make it look different so I can recognize to see if there's any factors that I could reduce. Okay, example 3. So we're going to set k plus 8 equal to 0. So k cannot equal negative 8. If it was negative 8, then our fraction would be undefined. So we don't want to have negative 8 in our fraction. Same idea. I'm going to factor the numerator to see if there's any common factors that I can reduce. So we have k. So factors of 40, that will give us 3. That would be 8 and 5. So plus sign means the bigger number is positive, and minus sign means they're different. So now I notice they both have k plus 8s. So I can reduce that. So you get k minus 5, and k cannot equal negative 8. And there's your simplified answer. So factoring to get it into something that I recognize so that I can reduce common factors. Okay, example 4. Right, set the denominator equal to 0. So x cannot equal 0. Otherwise it's undefined. Whenever you're simplifying, you always want to make sure you check the excluded values. What makes your denominator equal to 0? If there's one number, two numbers, 0 numbers, whatever it is, you need to make sure those are listed. So now I simplify. So I have 3 times x and 9 times x. So the common factors, right, I can reduce that x in one of those. The 3 becomes a 1 because it goes into itself 1 time. And it goes into 9 3 times. So now you have x over 3, and x cannot equal 0. So again, use factoring to make it so I can find common factors. Sometimes you might have to factor, sometimes you won't. Most of the time you probably will be factoring something, GCF, difference of squares, trinomial, something's going to be factored so you can make it look and be able for you to recognize the factors. Now, sometimes you're going to get an expression like x minus 2 and 2 minus x. Those are just opposites of each other. So by factoring out a negative, we can make them the same. So if you factor out a negative 1, now you have negative 1 times negative 2 plus x, which is the same thing as x minus 2. So, example 5, right? You're going to factor the denominator to see if we have common factors. So we have 6d, 1d, right? 1 times 1. So this is 1d, right? So this is 6. So that's not going to work. So 6 won't work. Okay. So that's not going to work for us. So then let's try 3d and 2d. Okay, that's 1d and 3d. Okay, so 3 and 2, that'll give us 1. So plus 1 minus. So set the denominators equal to 0. Add 1. Divide by 3. So d cannot equal 1/3. 2d plus 1. Subtract 1. Divide by 2. So d cannot be negative 1/2. So I set the two factors equal to 0 to figure out my excluded values. What makes your denominator equal to 0? We're going to exclude those values. So now I notice that there's a GCF in the numerator. So if I factor out a 3, that would be a 1 minus 3d. So we have 3d minus 1. We have 2d plus 1. So the 3d minus 1 and the 1d minus 3 are very similar. They're just opposites. So what if I change to, instead of factoring out a positive 3, a negative 3? That would change those signs. So now they're identical so that they can be reduced. So you get negative 3 over 2d plus 1. And d cannot equal 1/3 or negative 1/2. And that would be your simplified answer. And then example 6. Right, so we're going to factor both numerator and denominator because right now it looks like there's no common factors. But we want to make sure. So factor both numerator and denominator. So a times a gives you a squared. Multiples of 12, that will give me 4. So 6 and 2 minus 6 plus 2. A and a. Multiples of 42, that will give me 1. So 7 and 6. So plus 7 minus 6. So a cannot equal negative 7. A cannot equal 6. Where did that come from? What makes a plus 7 equal to 0? Negative 7. What makes a minus 6 equal to 0? Positive 6. So I see common factor of a minus 6. So those reduce. So all we have left is a plus 2 over a plus 7. And a cannot equal negative 7 or 6. And there's your simplified answer. So again, I factored it to make it look like factors that I might recognize, and I did see, oh, they both have a minus 6 as a factor, so I could reduce those. So the factoring helps you make the problem look different so that maybe you can recognize common factors. Wait, example 7, very similar to 6. So I'm going to factor top and bottom, right, numerator and denominator. So we have 2x, 1x. So we need the multiples of 6, multiples of 12. 1 and 12, 2 and 6, 3 and 4. Let's see, if we go 3, let's see, 1. No, not 1 and 12, that won't work. Let's go 3 and 4. Is that going to work? So this will give us 8x. That'll give us 3x. Yep, that'll be 5, so that'll work. So we need the negative 8 plus 3. And then we have 2x and 1x. So multiples of 4. 1 and 4, 2 and 2. So we have, let's try 4 and 1. That's 1x. That's 8. 8 and 1 will give us 9, as long as they're the same sign. So minus, minus. So x minus 4, set that equal to 0, and 2x minus 1. This will give us our excluded values, what x cannot equal, because then our denominator would be equal to 0. So subtract or add 4, divide by 2. So x can't equal 4 or 1/2. Do notice that they share x minus 4, so those reduce. So 2x plus 3 over 2x minus 1. And x cannot equal 4 or 1/2. And that would be your simplified answer. Okay, number 8. So again, right away, I don't see anything that kind of stands out to me, right? So what I can do, though, is I do see that there is cubes on top. So it's a sum of cubes. So remember binomial, trinomial, a, b. So a plus b, a squared minus ab plus b squared, right? From unit 2. And we saw this a little in unit 3. So in our case, this is 3y being cubed plus 5 being cubed. So you get 3y plus 5. And then you have the trinomial. So square a, so this would be 9y squared. Because you're squaring 3y, that's 9y squared. Minus a times b, so 15y. Because 5 times 3 is 15. And then b is 5, so we're going to square that. So there's the numerator factored. The denominator, right, we can factor out a 5, right? So 5 goes into 15, right, 3 times, so plus 5. So now I do see some uncommon factors, but before we go anywhere, right, set the denominator equal to 0. Subtract, so y can't equal negative 5/3. Well, what about the 5? Do I need to worry about that? No, because it's what makes your denominator equal to 0. 5 is always going to be the number 5. It's never going to become 0. If y happens to be negative 5/3, this would be 0 and the fraction would be undefined. So it's only when there's a variable I have to worry about that. So do notice common factors. The 3y plus 5's reduce. So you get 9y squared minus 15y plus 25 all over 5. And you might be thinking, oh, maybe I can factor the trinomial. Nope, we cannot. Remember, sum and difference of cubes, that trinomial can never be factored. So this would be your simplified answer. Okay, example 9 and 10 are just working with some notation. So g over f times x is g of x divided by f of x. So that just for us would be n squared minus 4 over n minus 2. Again, what makes the denominator equal to 0? So it can't be 2, otherwise the fraction's undefined. So that's my excluded value. Now I'm going to factor it to see if there's any common factors, because right now it doesn't look like anything. But the numerator is a difference of squares, n plus 2, n minus 2. Oh, now I see that there's common factors. The n minus 2's reduce. So this becomes n plus 2, n cannot equal 2. So to begin with, it didn't look like it had any common factors. But by factoring it, I make it look different, and I can see, oh, it does have common factors. Okay, number 10, same idea using the same information from 9. So g of x is n squared minus 4. And this says f of x, and you're going to square it. So n minus 2, that quantity squared. So same idea, what makes the denominator equal to 0, right? N cannot equal 2. So factor the numerator, that's n plus 2. We just did this, n minus 2. And the bottom is n minus 2 times n minus 2. So I do see they have common factors, n minus 2, n minus 2. It doesn't matter which n minus 2 you cross out in the denominator, just one of them reduces. So you have n plus 2 over n minus 2. And there's your simplified answer. So I was able to factor it again and make it look similar, or not similar, make it look to something I can recognize. Make it look like something I've actually seen before. Right, the last two problems are just practicing using your law of exponents to help you simplify. So first one here, right, we're going to use our law of exponents. So xy cubed is the same thing as x cubed y cubed. Xz to the fourth is x to the fourth z to the fourth, and then y to the fourth. And then the bottom part, x squared y squared, would be x to the fourth y squared. And then it's z to the fourth x to the fourth. Right? It's kind of like I'm distributing the exponent to each term. That's kind of like what's happening. So now I'm going to combine my variables, right? So I have x to the third, x to the fourth, so x to the seventh, y to the third, y to the fourth, so y to the seventh, and z to the fourth. Denominator, same thing, so I have x to the eighth, y squared, z to the fourth. And now I'm going to simplify. So the z to the fourth reduce. Remember, when you're dividing, you subtract your exponents. So I have y to the fifth, right? Because these two are gone, so there's going to be 5 left. All 7 of these are going to be gone. There'll be 1 left. So you end up getting y to the fifth over x. So I'm using my laws of exponents to kind of expand it so that I can regroup and combine the variables so that I can reduce them. So we're going to do a very similar concept as 11 with number 12. So we're going to simplify. So for example, in the numerator, 4 squared, that's 2 squared squared. So that would be 2 to the fourth. Because the power raised to a power, you multiply. 6 to the third is 2 times 3 to the third. So that's 2 to the third, 3 to the third, right? Like I distribute. And then you have 5 squared. Right? Now you can't break that down. Okay, the 12, right? I can break the 12 down to 4 times 3 squared. But 4 is 2 squared. So this would be 2 to the fourth times 3 squared. And then the 15 is 3 times 5. So times 3 to the 1, 5 to the 1. So very similar, except for now I'm using variable constants. So up top we have 2 to the 7th, 3 cubed, 5 squared. To the bottom we have 2 to the 4th, 3 to the 3rd, times 5 to the 1. And then we reduce. So we can see that all 4 of these are gone, and there'd only be 3 left here, right? These are gone, that's gone, and 1's left. So this would give me 2 to the 3rd times 5, which is 8 times 5, which gives me 40. Okay. So again, last two are just getting you used to using some of your laws of exponents that you'll see throughout the unit and just practicing simplifying. Please make sure you write a 3 to 5 sentence summary answering the essential question at the top of the notes, and then you'll be done with your notes. Have a great day.